Hey everyone, it's Solar Sunday at GazWeathers.com. We're going to do our first Solar Sunday update since August, can you believe? Haven't done one for 6 months, so we're well overdue for one. And today, well, this is it. I'm doing the first Solar Sunday update for 6 months. Big thank you to James, my good friend James Atquill, for supplying me with many of the charts that you're going to see in this video. I couldn't be doing this update, this Solar Sunday update, without the things that James has given me. So thanks so much to James. I know you're going to be watching, James, and thanks so much to you for giving me some of the information, or most of the information, actually, that's going to be appearing in this video. Now, just say about the ads, so I get on with Solar Sunday. There's links to articles on most of the pages at GazWeathers.com. Have a browse through the widgets, and any articles that you're interested in, please click through. When you do that, you'll be able to go for read those articles, and you'll be able to support GazWeathers.com. Thanks so much for doing that. These things are really paying for the website. So thanks for getting involved. Thanks for doing that. It's going to be quite a long video, so get a comfy chair, get a cup of tea or a cup of coffee, and maybe a few little snacks, a couple of biscuits or something, because we're going to be here for quite some time, but I hope you find it interesting. So I just want to start off with where we are with the sunspot cycle right now, solar cycle 24, and the best place to start really is where we are today when I'm doing the video. This is from solarham.net, and we can see that we've got very low activity just at the moment. Officially, sunspot activity today is low. We've only got a few sunspots, and they're sort of gathering around the equatorial regions of the sun, actually, which is where they tend to go as we gradually slip down in towards solar minimum. They leave sort of the northern and southern hemisphere, which is where you tend to get them early on in the solar cycle, and they sort of migrate into this central part of the solar disk. So anyway, that's where we are today. We have officially sort of low activity. Now, I can show you where we are in terms of the solar cycle up to December. James gave me this chart. This is the monthly mean sunspot number going up to the 31st December 2014. And you can see that we're just here, right over in the far sort of right-hand chart as you're looking at it. And we're lower in terms of sunspot numbers than we was last winter. This is where we was last winter at the start of 2014. And sunspot activity is quite clearly lower than that. This is actually the maximum in terms of the sunspot numbers anyway, monthly sunspot numbers. This is the maximum, but solar cycle 24. A very interesting solar cycle, this one, because we get a double peak, which isn't that unusual. We get the first peak happening at the end of 2011 into the start of 2012, just here. And then we get the second peak, which again, it's not unusual to get two peaks, but we get the second peak at the start of 2014. But what is unusual is that the second peak is ever so slightly above the first peak. I've spoken about this in other solar Sunday updates. It's quite unusual to get the second peak above the first peak, but that's what's happened with this solar cycle. Anyway, you can see, but where we are right now is just there. We're lower than we was start of 2014. We haven't really yet started dropping into solar minimum, though. I don't think. For instance, we're quite a bit above much of 2012, where it was in 2012. We had that first peak, of course, at the start of 2012, but then we get quite a dramatic drop down through the course of 2012. And overall, 2012 into 2013 has a lot of sort of low activity. It's not until we get to the second half of 2013 and on into 2014 that we get this second peak. So we're lower than we was last winter, and we're lower than where we was in 2011-2012 with this winter. But we aren't down in sort of this zone, which is 2012-2013. And I don't yet think we've started dropping down into solar minimum. We'll reach solar minimum around 2019-2020. This is all important, by the way. The reason we look at the solar cycles is because there's a connection, I think, between sunspot activity and European winter weather in particular. It's not so much the case for North America, not so much the case for Asia or other parts of the world, but there's a very, very unique, strange, unusual connection between sunspot activity and winter winter weather in Europe and the United Kingdom, and it's in the form of blocking. I think it happens because of solar flux and the impact that has on the jet stream. When we have a lot of solar flux, a lot of sunspot activity, we're tending to enhance the jet stream, really, which for Europe means that we tend to bring in mild air off the Atlantic, whereas when we have weak sunspot activity and solar flux, we tend to get more in the way of blocking around Europe. And of course it's blocking, locked in cold, that gives us our cold winters, not just in Europe but in the United Kingdom as well. So that's why we look at solar activity, one of the important factors for winter weather in the UK and Europe. By the way, we can see how this solar cycle, so cycle 24, compares to the last solar cycle 23, and that's this one just here. The maximum of solar cycle 23 is this just here, huge maximum at the start of the year 2000. You can see just how weak really this solar cycle is compared to this. So we're significantly below solar cycle 23, albeit of course we're still getting spikes in sunspot activity, but we're well below solar cycle 23 with the current sunspot cycle. Now this is a very interesting chart. Again, this is from James. This is the 11-year smooth average of monthly sunspots, and this puts it into context of what's happened really through the past few hundred years. This takes us right back to the year 1760, and the first thing to say is that through most of the 20th century we're actually increasing sunspot activity. So we start just here in the year 1900 for the 20th century. And you can see that through most of the 20th century, the sunspot numbers are increasing, and we get some really intense activity as we get through in towards the peak, which is the 1950s. In the 1960s, things do drop, quite a significant drop there in the 1960s, and that coincides with a colder decade in the 1960s. But then again, the activity increases once more through the 1970s and 1980s, reaching this peak just here, and then since around 1990, we've had a very, very dramatic plunge, and this is the blue line just here, plunging down to just there. And over the past 20 years or so, since around 1990, the sunspot activity, solar activity, really has been dropping, and that drop in activity is very, very much on a par with the drop that occurs just here. And this is back to the Dalton minimum. This is back to the start of the 1800s when we had two solar cycles, 5 and 6. That were very, very weak indeed. And I think you can see that the drop that's occurred now is sort of on a par with the drop that occurred at the start of the Dalton minimum from around the late 1700s into the start of the 1800s. Now, we haven't quite reached the depths of where we was in the Dalton minimum, which is this zone just here. We haven't got down to that at the moment. We're not as low as the Dalton minimum. But the drop that's occurred from sort of here in the past 20 years, the drop that's occurred is very much on a par with the drop that occurs just here. And of course, what we have to take on board with the Dalton minimum is that we're coming out of the Maunder minimum. So I can show you what the Maunder minimum looks like. You can see how, going back further and further with this, how everything that we're seeing now sort of plays into what happened back then. So this is what a Maunder minimum looks like. This occurs from around 1600 through to around 1750, and the peak of it is from around 1650 to 1700, where we have around a 50-year period of virtually no recorded sunspot activity at all. So that's the Maunder minimum there. I got this chart from Wikipedia, by the way. That's the Maunder minimum just there. Then in the second half of 1700s, we lift the sunspot activity up, and then of course we get to the Dalton minimum, which is what I was just talking about just here, which is solar cycles 5, solar cycles 6, and you can see that we do get a very, very dramatic plunge as we go into the Dalton minimum. But we're starting from a lower level. That's what I'm trying to get across with this, really. We're starting from a lower level with the Dalton minimum because we're coming out of the Maunder minimum, starting at a lower level than we currently are. So you perhaps can't compare this, what we see just here, the Dalton minimum. You probably can't compare that to this because this is starting from somewhere down there, right down there, whereas this, of course, is starting right up here. So I suppose if you was to look at it that way, the drop that's occurred in the past 20 years is probably even more dramatic, actually, than the drop that occurs just here, sort of just here. And the reason is that we start now from a much higher level than we was at for the Dalton minimum. Now, one thing that's been very apparent over the last year or so is that we're running very closely with Solar Cycle 24 to Solar Cycle 12. We're not running as close to the Dalton minimum, Solar Cycles 5 and 6, but we are running quite close to Solar Cycle 12. Solar Cycle 12 was a solar cycle that occurred from around the end of the 1870s, something like 1878 through to 1890, and the orange line here on this chart is Solar Cycle 24. The green line is Solar Cycle 12, and it's very apparent, isn't it, that the peaks and the troughs that are occurring through both of the Solar Cycles 12 and 24 are sort of very close together, aren't they? I think you can see that the first peak of both Solar Cycles 12 and 24 very close together indeed. And then for the second peak, of course, the second peak occurs in 2014, start of 2014, for Solar Cycle 24, just here. And we get a peak there as well, with Solar Cycle 12. So it is quite apparent, I think, that the solar cycles have been running, 12 and 24, have been running very close together to one another. It's very interesting how that's happening. In a moment, I'll show you the Central England temperatures for the winters of both the Solar Cycles 12 and the one we're currently in, 24. And you'll see that, again, the winter Central England temperatures have been running very, very closely together with one another. Now, we may be deviating a little bit right now from Solar Cycle 12. This thick green line is the smooth sunspot number for Solar Cycle 12. And you can see that at this point, actually in Solar Cycle 12, it was beginning to drop away in towards solar minimum. We haven't really started seeing a drop for Solar Cycle 24 yet. That's this red line just here. I'm not sure you can make that out terribly well, but once you see this red line sort of dropping parallel, if you like, to Solar Cycle 12, which is the green line. Be very interesting about how that happens. The drop in sunspot activity for Solar Cycle 24 will be occurring very, very soon now. It'll be interesting to see how that drop occurs and whether we continue to run quite parallel to Solar Cycle 12. Just a quick say about Solar Cycle 5, there was some speculation earlier in the solar cycle that we was running quite closely with 24, the one we're currently in, to Solar Cycle 5, which is, of course, the Maunder minimum, the Dalton minimum, I should say, the Dalton minimum. Solar Cycle with two solar cycles for the Dalton minimum, 5 and 6. Solar Cycle 5 on this chart, again given to me by James, is indicated by this blue line just here, and you can see that we are significantly above in terms of activity, significantly above Solar Cycle 5. So I think we've got to sort of forget that idea that for this solar cycle we're running close to Solar Cycle 5, the Dalton minimum cycle. We're much closer to Solar Cycle 12. But remember, the drop in activity that has occurred over the past 20 years is sort of on a par, and maybe even a little bit more dramatic actually, than the drop in solar activity that occurred as we went down into the Dalton minimum. Albeit we haven't yet reached the depths of sort of despair, if you like, the depths of low activity that we had with the Dalton minimum. Now I want to show you this chart that, again, James gave me. This is how the Central England temperatures for the winters of these solar cycles are running parallel to one another. So let's start with the very first winter, both cycle 12 and solar cycle 24, which is this one just here. It's 1877-78 for solar cycle 12, and it's 2007-2008 for solar cycle 24. And you can see, but the first winter of both of those, both solar cycles, is above average. It's milder than average with both winters for those two solar cycles. Go through to the second winter, and look at this, they both go colder than average. This second winter of solar cycle 12 is 1878-1879, a very severely cold winter that one was. The second winter of solar cycle 24 is 2008-2009. It's indicated by this light blue shading just here. So the second winter of solar cycle 12 was really severely cold, whereas the second winter of 24 wasn't anywhere near as cold, but it was colder than average, and it was the first colder than average winter for a long, long time. I'm sure you remember it, 2008-2009, the first cold winter for several years. And it's interesting how the first winter of both the cycles is mild. The second winter of both the solar cycles is cold. We go through to the third winter of both the solar cycles, and you can see that again, they are both cold. Look at that, they're both cold winters, and actually the winter of solar cycle 24, which is 2009-2010, is colder than the winter of solar cycle 12, which is 1879-1880. But they are both colder than average. The fourth winters, look at this, the fourth winters are colder than average. That includes December 2010. It's December 2010. December 2010, 2011, and 1880, 1881. So we start off, the first winters are, both solar cycles are mild, then the next three are cold, and then look at this, we go through to the fifth winter of both solar cycles, and we go mild. That's very interesting, isn't it? That the fifth winter of both the solar cycles, 12 and 24, go mild. That's 1881, 1882 for solar cycle 12, and it's 2011, 2012 for solar cycle 24. Now, we get through to the sixth winter, and this is where we get a deviation. Finally, after running sort of parallel, although not exactly the same, because of course this winter here in the 1800s is much colder than this winter, and this winter in 2009-2010 is colder than the one in the 1800s. So we're not identical, but the trend is very similar through the first sort of 5 winters of both solar cycles. But we get to the sixth winter and we deviate. For the winter of solar cycle 12, the sixth winter of solar cycle 12, we go above average. Not a desperately mild winter, but we do go above average winter of 1882-1883, whereas the winter of 2012-2013 is a little bit colder than average. Again, not desperately cold, but there is definitely a deviation there in the sixth winter of both the solar cycles. But look at this, we get to the seventh winter and we're back with the trend again. So this is 1883-1884 for solar cycle 12, and it's 2013-2014 for solar cycle 24, and they're both significantly milder than average winters, both coming out around 1.5 degrees up to perhaps nearly 2 degrees above average. So both very significantly milder than average central England temperature winters for the seventh winter of both solar cycles. And that brings us up to where we are now. We're into the eighth winter of solar cycle 24, and the eighth winter of solar cycle 12 is this one just here, this dark blue shading just here. You can see that it was a slightly milder than average winter, but significantly cooler or colder than the winter before it. The winter of 1884-1885 was significantly cooler, albeit still a little bit milder than average, than the winter of 1883-1884. Now, what's interesting here is that I think we're going to be very much on a par with this. James has put in where we would be if the central temperature for this winter, 2014-2015, was to come out at 5.2 2 degrees. I think it'll be a little bit cooler than that, actually. So I would suspect, we'll have to review this again, but I suspect this sort of blue box here will be even closer to this dark blue box once we get to the final number for this winter. And in any case, I think they are going to, again, be very, very similar this winter and 1884, 1885. The 8th winters of both the solar cycles are going to be very, very similar. Now, as we go beyond that, we can't go beyond that, of course, with this solar cycle 24, because we're right bang up to date now. But if we go beyond that with the solar cycle 12, you can see that the next 3 winters do go significantly colder than average. So if you like cold winters, you could have something to be watching out for here for the coming winters. The winters of 2015, 2016, 2016, 2017, and 2017, 2018. They could all be, if we continue this trend, and of course we have seen just here, back in 2012, 2013, we have seen that we can deviate, so it's not guaranteed that we're going to continue this trend, but if we was to continue the trend with solar cycle 24 and solar cycle 12 sort of being very similar, you would expect that we would go colder with the next 3 winters coming up. And that even goes on to the next winter as well, this one just here, which is 2018, 2019. And then after that, we maybe go a little bit milder than average. But then, of course, the final winter of solar cycle 12, which is 1890, 1891, again, it goes severely cold, and that would be around 2021 on James's projection. So there's a lot to be watching out for there, I think, if you like colder than average winters. It's very interesting how solar cycle 12, solar cycle 24 is sort of mirroring each other. They're mirroring each other very, very nicely, except for 2012, 2013, which deviates from its partner back in solar cycle 12. Except for that one example, all the other winters have the same sort of trend. They haven't been identical, as I've already explained. Some of the winters in the 1800s were colder than their counterparts in this solar cycle, and some of the winters in this solar cycle, interestingly, were colder than their counterparts in the 1800s. So you see that I'm getting at the idea that they're not absolutely identical, but in terms of the overall trend for the ones that are mild and the ones that are cold, there is a trend there. There's a similarity that's going on. It could just be random. I have to say that there may not be anything in this, but it's very, very interesting, and I've sort of taken this on board a lot. I took it on board a lot when I did the winter forecast, actually, for 2014, 2015, when I did that at the start of the winter. I took it on board, this chart, because I did think that there was quite good evidence there that we seem to be mirroring the winters in these 2 solar cycles quite nicely. So if you want cold winters, if you like cold winters, next winter, the one after that, and the one after that, they could have something for you. But let's not go any further with that one. Okay, I hope you found the video interesting. Hope I've not gone on for too long. Thanks for watching. Just to say, come back later to the ENSO page. You'll be able to find the link to it here on the homepage. Come back to the ENSO page later, because I'm going to be having a look at what's happening in the Pacific, and maybe doing a little bit of a projection, a little bit of a forecast for where the ENSO, El Nino, La Nina, all of that kind of thing, where it may be going for this year. So come back for that a little bit later on the ENSO page. That's it for Solar Study. Hope you found it interesting. Thanks for watching, and bye for now.